So we're going to be solving a problem in the advertisement space. Now, this is the data of a company. The company wants to know the click-through rate value. Click-through rate, that CTR, is click, in order to identify whether spending their money on digital advertisement is worth it or not. So these are different ads from time past, and they're wanting to know, okay, based off of these parameters of ads in time past, web page ID, the product category 2, group, the targets that they're trying, the targets. So when you're creating an ad, you specify the target demography, and the target group and all of that, and if it was clicked. So a higher CTR represents more interest in that specific campaign, whereas a lower CTR can show that the ad may not be as relevant. Good. So this is a company that wants to make an interesting data-driven decision, and they've recorded their moves from time past, and so based off of moves in time past, they are trying to make a more informed decision as to futuristic moves, if they should push out that particular ad or not, and if they push that ad, they want to get interesting returns from it. Good. So before we go ahead building the AI model, let's quickly try to visualize this data set using Autogon auto visualization, and we'll give this some seconds. Better ad position is actually very important. Visualization is done running. We can already see, so there's a heat map plot, distance plot, violin, pescata, and a carver plot. So I like to play first with the carver plot, but you can have your own options. So I am trying to evaluate is click as to product category. This is product category 2. So let's look at is clicked and age level, and we can see that younger people click on the ad more. User depth, okay, nothing much to see here. City development index, equal metrics across. User group ID, so we can see the kind of user group that is being targeted also really matters as to if the ad is actually clicked, and I believe this has a correlation with the age that we saw as well. Okay, beautiful. So let's jump right into building our model. So we can, out of all of these independent variable, now there's independent variable and there's dependent variable. So independent variable, all of these items, so we can see we have a very interesting data set here of 463,291 records, and all of these items aside the is clicked is the independent variable. So all of this is the independent variable and this is the dependent variable, and we are trying to predict what outcome the dependent variable is going to be, if that particular ad is going to be clicked or not. Great. So and we can see is clicked actually has so it's either a true or a false. False is 0, through means is 1. So yes, so take note of that. And this is a categorical variable, so this is a classification problem. Yeah, a binary classification problem, to be more specific. So let's go right into building our project. So I'll click on project and I'll create a project, and I call this CTR In Advertisement Prediction, and I can paste the same thing here, and beautiful. So there are 2 ways we can build machine learning models on Autogon AI. We can actually go through the Studio Wizard, or we'll go through the Studio. The Studio Wizard is an AutoML tool for building powerful machine learning models in few seconds, from leveraging 2 to 3 clicks, whereas the Studio route, it gives us a whole lot of flexibilities with the number of algorithms we can bring in. We can bring in multiple algorithms, even build out our own ensemble out of it. We can bring in deep learning and design simple to complex neural networks that is going to help us out with predicting the accurate value from our data set. But for the sake of this video, I'm going to be leveraging the Studio Wizard. So I'll launch the Studio Wizard, and I click on select dataset, and I'll select CTR in advertisement datasets. So we give this some seconds to run. So while this is running, Autogon AI platform has been tailored to aid non-technical users to be able to leverage data-driven decisions. So making it both advantageous for technical users and non-technical users, which is actually beautiful. Okay, so from this data set, we can already see the feature of importance. We can see the web page ID and the campaign ID is of high importance. You can also see the products categories are actually important, and this is the level of importance. User group is actually of major importance, and we can also see the age level. We also had an idea of some of these things while we were on our visualization end. Beautiful. And is clicked, you can see, is a categorical variable. So now we select next. Now what training type are we going to select? Classification. Yeah, you guessed right. Good. So what training target are we going to select? Is clicked. And if you got it, if you guessed right, beautiful. So then we're going to enter a name for the model, and any item you enter here actually is fine. There's no limit to what you can do here. So we'll just enter a beautiful name. I will call this is clicked, ads underscore is clicked, and we can just put an M to signify the model. Good. And I'll just click on the train button, and we give this some time to run. So our model is done building, and we have an accuracy of 0.93, which is 93%. Beautiful. It shows that our model is actually very highly performant. In a moment, we're going to be trying out our model. Let's look at the feature of importance as well, and we can see that products category 2 is of more significant importance also. So that means, okay, and the web page ID, the session, the campaign ID, and the user ID, but more on the product category 2 has a more extra significant importance to the target variable, which is clicked. Beautiful. So let's inference our model. So we can try inferencing our model with a new observation already, with a new advertisement that we're about to push out, to see if the model is already advising us that no, don't go this route. No, you're not going to get a return on investment for this particular ad, go this other route. But before we try out on a new observation, let's try it on existing observation for data sets that we have already. So right here, I have opened the data sets, and so this is the data sets we used in training the model. So if you look at the column names, yes, every single thing exists. Now, because we are trying to predict is clicked, so you can see all of these adverts was not clicked, all of this was not clicked, all of this was not clicked. Because we're trying to predict is clicked, we are going to copy all of the independent variable alone without copying the dependent variable. So we'll see what our model predicts of this independent variable to get the dependent variable. So we'll copy this independent variable here. Now we're going to use this to inference our model. And beautiful thing on Autogon AI, Autogon AI does not take this direct string like this to inference your model. It takes it in the form of data sets. And one of the ways you can create this is you come on quick predict and you select your model, your project, select the model, create data sets, and we'll drop this scalar item copied. We select one dimension and we click generate data set. Beautiful. If I copy this, now if you want to see what we've generated, you could always visualize it on your browser, and you see it has what we've just generated, 4.0 down to 0. But for this one we have 4.0, 0 and another 0, meaning this ad was not clicked. Beautiful. So we'll copy this particular new data set we've just generated, and we come to prediction. So we'll try to inference our model, and we can see this portion of test data sets. We enter the test data and we click on predict. I'll give this some seconds to run, and beautiful, we already have our YPred. And then if we scroll, we can see the model predicted that this particular ad is not going to be clicked, and it has a prediction accuracy of 0.9258. So it is very certain that this ad is not going to be clicked. Beautiful. So this is how a business can save themselves the stress and save themselves spending huge amount of money on advertisement by making data-driven decisions, leveraging AI advantage. So now let's look at another data set. So let's look at for this. So we copy this, another observation, we copy this, and we come create a test data set out of it, select one dimension, and we generate this. So for copy this, we can take this down to test data, and I will click on another predict, and let's see what our model says. And our model says this guy is not going to be clicked, and its prediction accuracy is 0.911, meaning in 91% sure that this guy is not going to be clicked. Beautiful. So let's look for okay, like this guy was clicked, we can see it was clicked. So let's take all of its independent variable, and we try to create a data set from it, and we select one dimension and we generate a data set. And we'll copy this and we'll come to our model and update the test data set, and we'll click on predict, and you see, oh, our model predicted that this guy is still not going to be clicked as well. Beautiful. But don't forget, we have a margin of error of 0. Let's be sure. So 0.68. Yes, so 0.68. So our model is 93.2% accurate. Okay, good. So let's try another inferencing again. Let's try this guy, and we'll create a data set from it. We'll select one dimension and we'll generate the data set. We'll copy it and we'll come right here to test data set, and we click on predict, and beautiful, we can see that our model predicted that this other observation is not going to be clicked, and it has a prediction accuracy of 0.87, which is 87%, roughly 88%. Beautiful. And you can see the guy wasn't clicked. So our model, from the little test we've just done, it's made out of 4 prediction, it made 3 correct prediction and 1 incorrect prediction. Yes, our model is highly performant. Good. So now I'm going to show us how to create a pipeline so you can inference your model from your back office system or through an API. So right here, for you to do that, you're going to need a pipeline. So we'll create a pipeline and we'll call this ads_pipeline. You can use any name, and we'll create the pipeline. Beautiful. So now that we've generated our pipeline, we can now navigate back to project details. Now when you navigate to your project details, you see the pipeline that you've created. So we can copy our pipeline. So before we go inference our pipeline from Postman, let's inference our pipeline from Quick Predict. So you can always test out your model from Quick Predict, and we pick one of the observations that we've generated in time past and input the link, run model, select the ads pipeline, and we click predict, and beautiful, our pipeline works. And we can see that this ad is not going to be clicked. Beautiful. So we can test out one more observation. We'll copy this particular observation and we take it right here. We can create a data set off of it, and one dimension, copy the data set, go to input link, and we'll update the link here. I'll click on run model, select the pipeline, ads pipeline, I will click on predict, and beautiful, our pipeline works, and it says this ad is not going to be clicked, and we can see the ad was not clicked. Beautiful. So now let's now test out our pipeline from Postman. I'll copy the same data set that I've generated here, and I'll navigate to Postman. So right here on my Postman, I already have a collection open. I'll update the data parameter, and I'll come straight down to project details, and I click on this particular project detail, and I'll copy my pipeline, and I could always come down to pipeline region here, and I'll update the pipeline ID, and I hit on send, and we give this some seconds to run, and beautiful, we can see we already have a prediction URL, and if I hit on send, I can see it came up with a prediction of 0. So good. We'll generate one more test data set. So if we generate for this, and we take this here and generate from the quick predict, we'll generate a data set off from it, and we select one dimension and we generate it, copy. Now don't forget the result here is 0, meaning that ad will not be clicked. So if we come and we change our data sets from the API and we hit the inferencing, open our prediction results, and we have a 0. Beautiful. So this is how we can make smart, swift, important data-driven decisions, leveraging Autogon AI, so the business can make an interesting decision to find out if it is worth that ad going out or not, yes, so they can save their money, save their time, and yeah, thank you very much.